Hello everyone, let's take a look at our next problem. Prove the statement using the precise definition of a limit. The limit as x approaches 4 from the right of 2 divided by the square root of x minus 4 is equal to infinity. Okay, so if you're just visualizing what the graph of this function looks like, the limit should more or less be obvious, but we're asked to do this using the precise definition of a limit. We have a limit of something going to infinity here, and it's a one-sided limit. So we'll have to think a little bit about exactly what the precise definition corresponds to here. But let me write down the statement and then try and write down exactly what the thing is we're trying to prove. So this is our statement. What we want to prove then is that let me write down the statement first, and maybe I'll explain it, but I kind of assume that you're familiar with this if you're watching this video. Okay, and let me just make sure this is exactly what we want here. With the one-sided limit, x minus 4 has to be positive. Even for this thing to be defined, x minus 4 has to be positive. So we don't have an absolute value in this thing. X is greater than 4, but not by much, only by a maximum of delta. And we want to show that we can make this thing as large as we want. Okay. Kind of like in other precise limit proofs, I'm going to do a little bit of rough work here and think about the best way of doing this. And then I will come back and put together the entire argument. Okay, I think I've worked out exactly how I want to do everything. And it ended up being a little bit more straightforward than I expected. Again, this is because the x minus 4 directly appears in the expression we're concerned with, the expression we're trying to make as large as possible. So by starting with x minus 4 less than delta and manipulating this inequality to end up with something just like this, makes it pretty clear how we should choose delta in terms of m. So if I choose delta like this, then this thing here becomes equal to m. So I'm going to go through the entire process here and put together all the pieces of what we need to get this proof done. So I can do this. This implication is true because so x minus 4 is positive, so we're allowed to take a square root or a power of a half. And taking the square root function is monotone, so monotone increasing, so it preserves inequalities. If I take a square root of x minus 4, that'll be less than a square root of delta. And then from this, I can manipulate this. Divide both sides by square root of delta and by the square root of x minus 4. These are both positive quantities, so the inequality doesn't change sign. Now multiply both sides by 2. Notice the thing on the right is exactly the function that we're concerned with. Now I've chosen delta to be equal to 4 over m squared. This implies that m is equal to 2 over the square root of delta. So the left-hand side of this thing is equal to m. And this is, in fact, exactly what we wanted to prove. So we're done. The only sort of piece that we had to figure out here was how to choose delta given m. And in this case, this is one particular choice that works, as I've shown here. And I came to that conclusion by just sort of manipulating the expressions involved, starting with this, manipulating it to get something that looks like this, and then identifying from this how to choose delta to make it look exactly like we wanted to prove. If I have any more to say about this one, I'll put it down in the description. Otherwise, thanks for watching.